Hello and welcome to the LINBIT community meeting. This is the June 2024 edition. I'm Michael and I work on documentation at LINBIT. If you're not familiar with LINBIT community meetings, we periodically have these meetings to bring the LINBIT team together with LINBIT software users, industry experts, and leaders. We have 4 scheduled speakers today. The speakers are developers at LINBIT and one solutions architect. They are going to talk about recent work that they have been doing, and today you'll learn about the LINBIT VSAN software. You'll also learn about a couple of exciting upcoming features that are in development for LINBIT's software-defined storage solution, LINSTOR. There will be a presentation from a LINBIT solutions architect about storage replication between data centers with LINBIT SDS software. And here LINBIT SDS is an umbrella term for DRBD, LINSTOR, and related utilities. Finally, you'll also learn about the DRBDmon utility for managing DRBD resources. In this community meeting, people from across all LINBIT departments are here, and this is a great time to ask questions of our team in real time. If you are attending this meeting in Zoom, you can either post your questions into the meeting's chat window or use the reaction button to raise your hand after a speaker is finished presenting. If you are watching this meeting on YouTube, you can post your questions in the video's comments section. We might not be able to speak to YouTube questions in real time. We'll do our best, but if we don't, we will answer the questions after the meeting. After asking any questions of our last presenter, there will be an opportunity to ask any general questions that you might have about LINBIT or LINBIT software. So today our first presenter is going to be Christoph, and like many LINBIT developers, Christoph works on a few different LINBIT software. Today, Christoph is going to be overviewing one of these. That's LINBIT VSAN. If you aren't familiar with it, LINBIT VSAN is a software-defined storage solution with a graphical user interface, and this makes it easy for you to create NVMe over fabrics, iSCSI, and NFS data stores. And with that introduction, I will hand over the microphone to Christoph.
Yes, hello everyone. Thank you for the introduction, Michael. Let me just get that screen share up. All right, so I'm Christoph. I work for LINBIT partially or in one capacity as maintainer and lead developer of LINBIT VSAN. And we will spend the next, let's say, 10 to 15 minutes kind of giving a technical overview and answering the question, what is LINBIT VSAN and how can you maybe use it to your advantage? This isn't supposed to be like a sales pitch. It's more of a behind the scenes on how the technology behind it actually works and what's kind of some strong use cases for it. Right, so let's get into it with, I guess, the executive summary. So LINBIT VSAN is a virtual appliance that exports software-defined storage through highly available iSCSI targets, NVMe over fabric targets, and NFS exports. So that's kind of the headline, but let's look behind the scenes and take a look how we actually do that and what's the benefit of this approach. I find that a nice way of visualizing it or explaining that the concept behind it is by taking a look at a standard technology stack that you would use for such an application. So let's look at it from bottom to top and start with hardware. Obviously, you will want some hardware. It doesn't really matter if it's real hardware or like virtualized hardware, but I will touch on that a little bit later. Obviously, on top of that hardware, you want some operating system. Of course, we will be using Linux. Again, it's for most deployments, it really doesn't matter which one you use. There are, of course, differences, but let's roll with a Rail-based derivative. Let's go with Elma Linux. Of course, on top of that, if you want highly available storage, there's no way around DRBD. I guess most of the regular audience of this meeting will already be familiar with DRBD, but just a quick summary. Basically, DRBD is a Linux kernel driver that replicates your data from one node to another node or multiple other nodes. So basically, you can build redundant storage clusters that way so that your data doesn't get lost. On top of that, again, a product that probably most viewers will already be familiar with is LINSTOR. And we obviously want that because it makes orchestration of DRBD resources, among other things, much easier. And we can kind of keep our nodes together and go from our SSDs and NVMe drives and hard drives to software-defined storage, where we can actually define our storage pools and resources and stuff in software across the whole cluster. Then another component that we might use for this is the DRBD Reactor, and you may not have heard of that before, so let me briefly explain it. I'll get to that a little bit later too. So DRBD Reactor is basically a high availability resource manager for DRBD-based clusters, and we can use that to export iSCSI targets and stuff, and I will get to that later. Another component that you may have not heard before, but which is crucial to this whole thing is LINSTOR Gateway, and basically this orchestrates our LINSTOR resources and our DRBD Reactor configuration to create highly available iSCSI targets, NVMe over Fabrics targets, and NFS exports. So we now have a pretty robust software stack, and again, I'll go into the details of some of these solutions later, but this works very nicely for exporting iSCSI storage and NVMe storage and NFS storage. And if we combine all of that software, so basically everything except the hardware, oh yeah, and we also have a graphical user interface, which I will also show later. So if we combine all of that software into a package, that's what we call a LINBIT VSAN. And then we wrap a wizard, a setup wizard, and some default configuration around that, so it's easy to use, but that's basically what it is. All right, so let's look at some of these separate parts a little bit more in detail. So I already talked a little bit about DRBD Reactor. It's a open source component. You can find it on our GitHub. And one part of it is it's a highly available or high availability resource manager for DRBD-based clusters. So basically what that means is we have redundant storage, we have replicated storage with DRBD and maybe with LINSTOR. And what we want is wherever that storage is available, just run some service. And this may ring a bell if you're familiar with Pacemaker, which is a pretty important piece of software and a pretty widely used one for doing exactly that kind of thing. So running highly available services on top of replicated storage. But at least for these use cases, we find it to be a lot simpler. And you will note the asterisk there. There are a few limitations to that. Of course, the DRBD Reactor has way less features. So for example, with Pacemaker, you can define all sorts of rules and co-location constraints and stuff like that. And it gets complicated very quickly. The DRBD Reactor has almost none of that. But again, we think that this is an advantage for the kind of use cases that we have in mind for LINBIT VSAN. So just a few words. This isn't a DRBD Reactor deep dive, but it's just a few words on how it technically works. So basically it reacts to changes in cluster state, as the name already implies. So every time something changes within the DRBD, we can react to that and kind of execute some action. So the question we are asking at all times is there some DRBD resource that can be promoted? And if so, then promote it. So make it writable and start some service there. And that service may be a systemd unit. That's kind of the simplest case, or it may be a resource agent, which is the ready-made piece of software that comes with the Pacemaker that starts, for example, iSCSI targets and stuff like that. Right, then another piece of software that you may not be familiar with is LINSTOR Gateway. It's also open source and also available via our GitHub. So this is kind of the whole heart of LINBIT VSAN. It's what makes it run. What this does is it uses DRBD storage orchestrated via LINSTOR for replicating your data, and it uses DRBD Reactor for starting highly available services. And these highly available services are either an iSCSI target or NVMe over Fabrics target or NFS export. So that's kind of the final link of what we need to go from our replicated storage to actual iSCSI or NVMe or NFS exported storage. And the nice thing about that is it uses the standard quote-unquote resource agents that also come with pacemaker. So if you've built a highly available NFS server before with using pacemaker, this like the actual service part is very likely to be exactly the same code. So it's kind of tried and true, only in a different package, so to speak, that we find works better with DRBD and that whole ecosystem. Right, so then we also have, we don't only want to make it work, we also want to make it easy to administer and to manage. So we have we have a proprietary product from LINBIT, which is a LINSTOR GUI. And this exists for LINSTOR in general, but it also has a special mode, especially for LINBIT VSAN. And I will show this off in a live demo later, but we can see here that we can like define iSCSI, NVMe, and NFS exports nicely from the GUI, and we can also do some administration tasks like updating the software on the nodes and stuff like that, and kind of monitoring how big our storage pool is and all that sort of thing. Right, so that brings us back to LINBIT VSAN, which is the sum of all that. So another like glimpse behind the scenes, I guess, is specifically we use STST for our iSCSI target, just because we found that works pretty well with a lot of hypervisors, and we just use the standard NVMe over Fabrics target that comes with Linux and the standard NFS server that comes with Linux. Yeah, and in addition to all that software, what we also provide is a setup wizard. So that the idea, I guess, is you just bring the hardware and click through a couple of setup points and it's all done. Yeah, it also configures some nice defaults for you that we have found to work very well with DRBD-based setups. So one of those is Quorum. And I bring that up because a limitation of LINBIT VSAN, I guess, is that you need at least 3 nodes for it to work. But an important point here is that only 2 of those nodes actually need storage, and one of them can be very slim, so to speak, and doesn't need any storage, it just needs to be connected to the network. But anyway, if you have been dealing with or have been using DRBD for a long time, you may have come across a split brain scenario, which is when in a 2-node cluster, when the 2 nodes disagree on which data set is actually the correct one. And Quorum, in a nutshell, is kind of designed to work around that and to prevent that from happening. So that's just one example of the protections, I guess, that LINBIT VSAN configures automatically for you, and so that you have one less thing to worry about. Right, I already mentioned the graphical user interface, but that also applies to the setup. So it's just clicking through a setup wizard, a web-based wizard, and then you get to the web-based LINSTOR GUI, where you can administer everything from your browser. Yeah, and then just another technical detail, I guess, is we use Elma Linux as the base OS, and we just modify the ISO installer, the regular ISO installer. So if you've ever installed a RHEL-based operating system or like a RHEL derivative like Elma Linux or like CentOS, it's pretty much that process. So it should be familiar to a lot of people. And then just some wizard questions on top of that. So it's really pretty simple to install. Right, so let's look at a few different scenarios where, or a few different setups, how you could deploy a LINBIT VSAN or common ones. So one of those is just using bare metal hardware. So we have 3 hardware nodes here at the bottom. And we just install LINBIT VSAN directly on the hardware, like insert a USB drive and just install it, and that just works because it's based on a regular Linux distribution. And then those 3 nodes, hardware nodes, will communicate with each other. And as one, they will export one highly available storage target. So be it iSCSI or NVMe or Fabrics or NFS, or all 3 actually. So they just export that, and then you have a hypervisor, or actually multiple hypervisors. Doesn't really matter how many you have, and they can all consume that storage. For example, with VMware, you could have a VMFS on top of that, and then like drive 3 hypervisors with that or something like that. And that's often used by people that already have an existing virtualization environment and just want to offload some of the storage work to additional nodes. And that's very helpful in that case. And another option is using hyperconverged architecture, where you also have 3 hardware nodes, but you run the hypervisor on these nodes. So for example, let's say you have 3, I don't know, Hyper-V hypervisors on there. On each of these hypervisors, you create a virtual machine. And in that virtual machine, you install all of that software stack that we talked about before, LINBIT VSAN. And it works just as well because, as I said, it's just a regular Elman Linux installer, so it works in the virtual machine as well. And again, they export one iSCSI target, one NVMe over Fabrics target, one NFS export, whatever we want to export here, we can. And then we feed that back to the hypervisor. So the hypervisor itself consumes the exported storage. And that's very nice if you're, for example, if you're planning a virtualization environment from the start and you have the ability to kind of allocate some compute power and some RAM and some disk space specifically for LINBIT vSAN, that can work out pretty nicely. Which way you use depends on your specific situation, but that's just 2 of the possibilities there. Right, so just a brief overview of the use cases we had in mind for the whole solution. So what we had in mind is small and medium-sized virtualization environments. So you can see on the right here is just some examples, not an endorsement or anything, but just a random pick of some players in the industry. Basically anything that consumes iSCSI, consumes NVMe over Fabrics, and consumes NFS is viable here. But I also want to touch on some points where maybe LINBIT vSAN doesn't make as much sense. So if you have, like, for example, take OpenNebula, where we have a LINSTOR driver, it wouldn't make much sense to use iSCSI via LINBIT vSAN there. It would be better to use the native OpenNebula driver. But if we don't have a LINSTOR driver, LINBIT vSAN can be a good fit. And it's also a good fit if we have some specific storage protocol requirements. So let's say we have a bunch of Linux nodes, and for some reason, some software expects us to expose an iSCSI target. Then LINBIT vSAN is nice for that, and we can use it as kind of an adapter from DRBD storage to iSCSI. Okay, I hope that outlines it a little bit. Let me very quickly demonstrate some of that. Just to show you kind of the look and feel and what it looks like. So I have a demo setup here, just a 3-node cluster of LINBIT vSAN nodes, and this is what the GUI looks like. We have some storage here. It's just 2 GB because this is just a demo deployment, and it's LVM thin. And I skipped the setup because it takes a few minutes and it's pretty boring to look at, frankly. But once it's finished, it looks like this. And then we see here that we can browse through our iSCSI targets, NVMe targets, and NFS exports. Of course, we don't have anything yet, so let's maybe create an NVMe over Fabrics target. And I have a resource group created here. It's on the SSDs and it has 2 replicas. We have to choose a service IP where the target will be reachable. So that's just some IP on the network that's not used already. Okay. Let's call it demo 1. Right, of course, I already did that before. Yeah, anyway, so we could then look at the targets here. It just shows how much space there is available in the target, and we can also, like I said, update our nodes, and yeah, look at LINSTOR error reports and stuff like that. Yeah, so I hope that's kind of gives you an overview of how the whole solution works. And I'll give it back to Michael. Thank you.
Thanks, Christoph. I guess now we will open the floor to any attendees who might want to ask Christoph a question. I don't see any questions in the meeting chat. If there are any attendees who want to ask Christoph a question, raise your hand now. And I will defer to RT and Niels, who are monitoring the YouTube broadcast of this meeting, to ask any questions in the comments there.
Yep, nothing yet on the YouTube side.
Okay. Well, if something occurs to you later in the meeting, there will be a chance at the very end of the meeting to ask general questions. So our next presenter is Gabor. Gabor is the LINSTOR lead developer and heads the team that develops the software-defined storage solution. Gabor is going to present on some exciting LINSTOR features that are in development. One of these is an enhancement to the LINSTOR autoplacer, and this will give you more control over where LINSTOR places resources. And the other is a new LINSTOR command that will make it easier to make mesh connections between LINSTOR satellite nodes. And with that, I will hand the microphone over to Gabor.
Thank you very much. I hope you can see my screen right now. Okay, so after this wonderful introduction, I guess I can jump right into the presentation. As already mentioned, I will talk about two different features of LINSTOR which are in development right now. One of them is how LINSTOR, or an additional option, how LINSTOR places resources. And the other one is how LINSTOR can or could connect DRBD resources with each other, but we'll go into details right now for this. Okay. So let us consider following setup. We have 3 data centers with a few disk-full nodes in each of them. And for the very first step, we need to tell LINSTOR where these nodes are, more or less. So LINSTOR obviously have no location knowledge about these nodes. So we simply run a simple LINSTOR command, node set property. The DC property is an arbitrary property, which I just came up with for this presentation. So this has no special meaning within LINSTOR. It's just a property I made up literally. And we separate our nodes in the locations, so to say. So we tell LINSTOR where each of these nodes is. What LINSTOR currently supports is the replicas on different. Some of you might be already familiar with this, which if you run the command that is shown right here, LINSTOR will select one resource from each data center. This is the replicas on different, what this is configuring. However, what the users actually requested is that they want to have 2 replicas in one data center and, for example, 1 replicas in a second data center, or more complicated combinations. But right now we tried to solve this problem or this request from the users. So we basically took the old replicas from different command and extended it. We had to rename or additionally name a second option called X replicas on different, which has now 2 parameters, for one the aux/DC as previously, but additionally also the number of how many resources can be placed in one of these data centers. So in this case 2, which unsurprisingly gives us exactly the solution which we were looking for. If we, just for to give you a few more examples, if we play around with the parameters shown here, if we, for example, increase the place count to 4, we will get a second replica in the already selected data center. So LINSTOR is not allowed in this case to choose a third data center because we configured it that it is allowed to choose 2 replicas per data center. So it first has to fill up these groups before it is allowed to choose a new group, so to say. But if we increase even further the place count to 5, LINSTOR has no other option. It has to choose the third data center. On the other hand, if we now play with the new parameter, if we increase the X replicas on different to 3, LINSTOR now is again forced to use already 2 of the already selected data centers. So we end up in this scenario. All right, that was quite brief, but this X replicas on different is, of course, combinable with every other existing autoplay setting. So it is just another tool in the toolbox for the autoplacer. And this whole feature is all about, just to briefly reiterate, to tell LINSTOR what nodes to select when you want to place resources, which I wanted to highlight here because the next feature, the path mesh, is a very different feature where we are talking about DRBD connections between nodes. So no nodes are selected here, but we are talking about the connections between those nodes. I just wanted to make this clear. All right, so let us consider the following setup. We have 3 nodes. Right now we have only 1 data center. We will go into an example later on where we have more than 1 data center, but for now, let's stick with 1. The lines here represent the DRBD connections. So if we run a cat command, most of us should be quite familiar with the DRBD res file. This whole path mesh feature is dealing with this connection blocks here and how to generate them, how to differently generate them, and what we can do with it. In case you're wondering how LINSTOR gets to these IP addresses, at the time when you run the LINSTOR node create command, the client is resolving the hostname, gets the IP address, so that LINSTOR can automatically create you this default net interface for you. And if you don't specify anything else, LINSTOR will use this network interface for controller to satellite communication, as well as for DRBD replication, which is something that you might not want. It's fine, so it works. It's not a problem, but you might want to use a dedicated network for DRBD replication. All right. So to make things more interesting, our goal is to actually have 2 replication links between all 3 nodes. This goal is currently achievable using the node connection paths. It sounds similar, but this is not the path mesh, this new feature. This is not the new feature called path mesh, sondern this already exists, but it has a problem, which I will come to later on, but I just wanted to show you how it is currently doable or achievable. So first of all, we need to create new network interfaces in LINSTOR. For each node, these 2 commands need to be run, which gives us the following interface list. This actually also addresses the issue that I was talking earlier. We now have the first default network, which LINSTOR will use for controller to satellite communication. And we give LINSTOR new tools to use the NIC1 and NIC2 network interface for DRBD replication. Good. The next command is actually quite a lot of commands, because for each pairs of nodes, we need to run these 2 commands, which does work. So this is the resulting resource file, which is exactly what we wanted. However, The problem is that with 2 replication links, for 3 nodes, we need 6 node connection path commands. For 12 and so on, and I'm pretty sure you can see that this scales quite badly. We have customers with a few hundreds of nodes, so you can run the math, but this does not look good. Okay, so what is the new method, the new upcoming feature for this problem? We start with the same setup. We still need to tell LINSTOR what interfaces to use. We will not get around of that. But next, we will only need 2 commands. So this is for each path mesh, not for each pairs of nodes, and not just for 2 path meshes. Just run these 2 commands, and you're basically done. By default, path mesh creates a full mesh from all participating nodes. So you will basically get exactly in this scenario what we tried to achieve. These are some of the options we are currently planning for the path mesh client. There might come more options, I'm not sure. As I said, this is still in development, but these are the ones that make sense that I will also demonstrate the first 2 of them in 2 quick examples. But yeah, the main thing of this path mesh is that it starts with a full mesh, and these options which are shown here are used to limit this full mesh, to exclude certain connections, to have more control about what kind of mesh LINSTOR should generate. So as I said, let us consider 2 examples. For the first example, we have a very simple setup with 2 worker nodes or diskless nodes and 4 storage nodes. Again, we have to tell LINSTOR how we differentiate between these 2 types of nodes. Again, the type property has no real meaning in LINSTOR. It's just an arbitrary property that I came up with. Next, as I also mentioned, we need to tell LINSTOR the interfaces, what LINSTOR can use. And next is the one option for the path mesh create, which is the path between different aux/type, which tells LINSTOR to only create connections between 2 nodes with different types. So between diskless and disk-full types, but not between 2 disk-full types. That's the reason why the connections at the bottom of the picture are missing. Those we can create with the other option, the path between same. So in this case, we have told LINSTOR to use the access network interface for, well, accessing the data from the diskless point of view, and use the replication network interface, well, you have guessed, for the replication itself. So this is a quite easy way to separate different networks for your setup. Let us consider real quick a second example. Now we do have 2 data centers. Again, we have to start similarly to tell LINSTOR where these data centers are. And again, we do this path between same, which, sorry, I forgot to mention, all of these 6 nodes are disk-full nodes in this case. So by us telling LINSTOR to create a full mesh, path between same means that it creates 2 full meshes within each data center. This is also what we see right now. And the next command basically tells to, well, generate the opposite of this full mesh. So path mesh 1 and path mesh 2 combined does create a full mesh. So it does not really look that useful, this example, unless we want this additional command that we tell that this path mesh 2 should run protocol A, which means that DRBD will replicate within the data center in protocol C and across 2 data centers with protocol A, which is also something that some of our customers actually asked. And that's basically already sums it up. So thank you for your attention. Are there any questions?
Thanks, Gabor. And yeah, we'll now open the meeting floor to anybody that might want to ask Gabor a question.
I have a question.
Sure.
Hi Gabor. So can you share your screen again with the X different X replicas on different command, and can you show me what if I want to have 2 replicas on 3 data centers across? So every data center should have 2 replicas.
So something like this, but with an additional blue node, right?
Yes, that's correct. Is that possible?
Yeah, sure. And the only thing you need to do is to change the shown command to place count 6.
Okay. So when you change the place count to 6, it will create 2 copy on data center 1, 2 on data 2, okay, and data 3.
Exactly.
Okay.
So
Okay,
what
that's
this
pretty neat.
parameter, this orange shown parameter 2 tells LINSTOR that every group, and by group I mean data center group, is allowed to be 2, have a size of 2 at maximum. And if I tell LINSTOR to create 6 replicas in groups of 2, then it has no other option than to create exactly what you are asking for.
Okay, okay. Okay, yeah, cool. Pretty neat. Thank you.
Yeah, very, very cool. We did have a question come into our YouTube broadcast, and that is, do you have any plans for a feature where someone would be able to control where tiebreakers are placed?
Yes, we have some sort of control over that because the LINSTOR's autoplacer distinguishes between the set of storage pools and the set of diskless storage pools. And the tiebreaker obviously looks only into the diskless storage pools. So this is a little bit of control, but for more detailed control, I'm not. We do have some thoughts, but nothing concretely planned for the near future.
Okay, thank you for that answer. Unless there are other questions, not seeing anything in the meeting chat. Oh,
I think
there's a
Brian
question
has.
from Brian.
Yeah, Brian had his hand raised.
I cannot hear you, Brian.
There we
You're
go.
on
How about
mute.
now?
Yes.
So on the X place replica count, when you had changed it to 5, it put 3 in the one day in Paris, instead it took the one out of Vienna. Is there an option to like say that you want as equal split as possible? So like on that, like if you said place count 5 replica on different 3, and perhaps this is my misunderstanding of the command, but if it were me, I think I would rather have an extra copy in a different data center, right? For redundancy.
Right, I see what you're asking, but right now what the best you can do is to leave it like this. So to keep this X replica on different OXDC on 2, which means that again the maximum group size is 2. So it's either filled
Okay.
up, or to be more technical, there is only one group allowed that is not completely filled up. It's a little bit mathematical, but it describes the approach the best, I think.
Okay, yeah, that helps. Thank you.
Okay.
Okay, thanks again, Gabor. Our next presenter is Yusuf. Yusuf is a solutions architect at LINBIT, and like other solutions architects here, Yusuf plays a key role in consulting with customers and potential customers to ensure that site design and LINBIT software use is the best that it can be for what you might be trying to do with it. One of the ways that you can use LINBIT software is to not only have local site high availability, but also disaster recovery across other sites. And Gabor showed a bit of that. Today, Yusuf will specifically present on some of the challenges that you might face and how you might overcome them. And Yusuf will use a 3-site cluster as an example use case. Take it away, Yusuf.
Thank you, Michael. Hope everybody can see my screen pretty well, right?
Looks
Cool.
good.
Okay. All right. In this presentation, I will try to give you an overview what our clients actually faced as a challenges when it comes to replicating data between the data centers. And there are various different types of installations when it comes to replicate data between data centers. There are different needs, there are different types of requirements. So I will try to explain as much as I can, but obviously this is a huge topic. And if you have any more questions after this one, please reach us out. I mean, we are happy to give you more information about that. And so yeah, let's get started. I mean, so why it's important to have an SDS solution, the software-defined storage solution that is flexible enough for a different implementation. We all know that nowadays applications are not just running in one single data center or one single machine. They are now complex, using sometimes partially cloud, partially on-premise, partially data center approach deployments. So the IT departments are really having a hard time to match the requirement on the application deployment. So sometimes you need to have a data replication for just a single database. Sometimes it's for multi storage VM solution. That's why you always need to have a reliable SDS solution under your system. Another thing is the multi-data center infrastructure, just like Gabor showed us. Lots of companies have multiple data centers now. Sometimes it's for the disaster recovery, well, just like the right-hand side. Sometimes it's for the active situations because they have multiple deployment, multiple sites that is actively running on different applications. And obviously, a disaster recovery is always a requirement, you know, because the application needs to be highly available at any given time. So, and they have some certain procedures that they need to take care of. So, disaster recovery is also another requirement. I mean, I have done too many POCs lately, and I can clearly say that the modern IT infrastructure is moving through hybrid infrastructures and moving to open source. We all know what happened lately in terms of hyper-converged market, also the hyper virtualization market. And people are trying to find a solution, a mix of on-premises, maybe private cloud and public cloud, and they want to have a single solution that matches all of the requirements they have in this complex environment. And they also want to get rid of this vendor lock-in situation where open source solutions come in handy, because they don't want to get bite twice from the same place. So they want to have a open source storage solutions as well as the open source virtualization solutions. Sometimes it's otherwise, but in any ways, they want to have a freedom to choose the best platforms of their need. So moving through the hybrid environment, having the open source, and also obviously they need an optimized solution for their workload, because if they choose a solution that it's not matching their needs, then what is the reason to go with that? They need a high performance solution for what they need. That's why it's really important to find a storage solution where it's flexible, reliable, and working with multiple type of deployments at the same time. And it also should be an open source. So just like I mentioned, the challenges, there are a variety of different challenges in the market right now. The complexity is one thing. So the latest POCs that I did, people are always considering easy installation solutions because they don't want to get lost with the user guides. They don't want to get lost with the installation manuals and so on. They just want to make it work. And obviously, one company cannot just choose nowadays just a Kubernetes environment or just a virtualization environment. Sometimes they need both. Sometimes they need more even. So they don't want to manage multiple different storage solutions within their infrastructure. So the complexity needs to be go down, which is going up every day. So they want to get rid of it. And obviously, the things that I mentioned, like different platforms have different API storage formats, management tools, and leading to operational overhead. They need different teams. For example, I was talking with a government institution a couple of days ago, and when we talk about if they are open to test a new approach to a storage, they say we don't have enough people to take a look at it. So this is a common thing that I always hear. They don't have the team to explore. They don't have the team to test things out. So they just want to make things work. And they don't want to expand their operational workforce. This is really important. And another challenge is performance, obviously. The performance is a huge issue when you replicate the data between two data centers, because when replicating data in the data center, you most likely have nowadays, let's say 25 gig is a standard. You have sometimes, I don't know, 40, 100 gig. The things are becoming cheaper and cheaper every day. So, but when you do it between the data centers, you are lacking of high throughput and low latency. That's why you are losing the consistency of performance. And also you have high RTO, high RPO if you are going through and using traditional storage environments. And that might struggle to meet these demands, obviously also impacting the application performance or VM performance. And the cost optimization, obviously another thing. The more storage you buy, the more money you pay. And these also, just like the traditional storages, the cloud storage offers also has the flexibility, but can be very expensive when it comes to the consume. So this is also another thing, also another vendor lock-in that people try to avoid. And optimizing the storage costs across the multiple data centers, multiple cloud vendors is really important. And the multiple choice of orchestrators. So when I talk with the prospects and customers, most likely they come to us with a single orchestrator. For example, they say, okay, we are considering using Proxmox, and we are looking for a software-defined storage solution, and we find you. And during the call, when I explained them that we also have the drivers and APIs for CloudStack, for OpenNebula, for Kubernetes, and many more, they are amazed about this, and then they start exploring these options also. And because the SDS should be able to match these demands, because if you have these kind of vendor lock-in situations that you only can use your storage solution with, let's say, one single orchestrator, then you obstruct the internal innovation, which is not really good for any kind of IT infrastructure. It needs to improve over time. Another thing is compliance requirements. Obviously, we need HDPR, GDPR, and many others in the market. So the compliance requirement is a thing that needs to be properly handled by the storage and the orchestrator level. So how do we solve it? I'm guessing you already know how LINBIT SDS works, but I think the beauty of LINBIT SDS is truly a true separation of the controller from the data plane. because when you do it, you have more flexibility than any others in the market. When you have two nodes between two data centers that you need to replicate data in between them, if you have a one controller which also controls the data plane, which also flows through the data flow, the I/O workload, this is a huge issue, because if you lost the controller, most probably you will also losing your data, and it will affect your performance and so on and so on. But you can completely destroy LINSTOR services while everything is running. While your data replication is running, the only thing gets affected is the creation of new VMs, for example, or new Kubernetes pods, persistent storages, and so on. So the separation of the LINSTOR controller is a true advantage when it comes to managing multiple LINSTOR deployment in between different data centers. You can have one single controller that manages both data centers from a third data center, for instance, or you can have two LINSTOR deployments between two different data centers where they send the data, each one of them. So that's also a possibility. So the flexibility and performance that comes with the LINBIT SDS obviously is a huge plus. It's a deployment agnostic. I mean, you can put it onto bare metal, virtual machine, containers, whatever you think of. So this way you can have you can think of an easy way to have replication between two data centers, because you can deploy HP servers on one data center, IBM on another, and Dell on the third one. And as long as you match the performance in between them, LINSTOR doesn't care about it, because it's completely transparent to the LINSTOR. So this is another huge plus when it comes to the replication. And future proofing, I already explained. The vendor lock-in and the open source is a huge thing, that when you want to have a proper software-defined storage, and the one software-defined storage for all orchestrators, another thing. For example, you can have Kubernetes on one data center, while Proxmox on another, while your controller is on a third data center, which is handling both of the nodes at the same time. Because LINSTOR has these properties where you can define like storage pools and resource groups, resource definitions. You can separate things within LINSTOR. You can define data centers in LINSTOR. That way, you can also separate the workload from one to another. And obviously, the simplified management. The LINSTOR has GUI, CLI, or if you want to use it with drivers for the orchestrators or the API, obviously we supported many others. So you can manage your storage consistently across all the environments with one single LINSTOR. And yeah, so I will just show you two ways of three data center deployment with LINBIT SDS. So one of them is the stretched cluster, which is somehow very popular these days among with our POCs and the customers. So what we have here is, so we basically have two active data centers, DC1 and DC3, and the VMs have been created in these data centers and distributed between these data centers. So while VM1 is actively working on DC1, the VM2 can run on DC2, 3, and the VM3 can be run on DC1, and so on and so on and so on. While these diskful replicas residing on another data center, so let's say you lose one of your data centers completely, your workload can be run from another data center, and the only thing that you need is to power up your half of the VMs. Obviously, your orchestrator can operate that power up section, but you can also do it manually. With this stretched cluster, you're basically balancing the workload between two different sites. As you can see here, the DC2 is for the tiebreaker nodes. You can place one single node for the orchestrator management, the LINSTOR controller management, and for the tiebreaker for the DRBD. So basically, you're putting all of the management aspects into one data center, which is also highly available. If you lose the DC2, every management service will be failover automatically to one of the other data centers, either if it's an orchestrator management or LINSTOR management, they are all highly available, or the VMs are already being replicated between the data centers. So the question is, so how do we do it? So we have a couple of ways of doing it. Sometimes the customers have dark fiber between the data centers, which makes it really easy. It looks like a local connection, obviously. Sometimes they have site-to-site VPN with a pretty good connection. Then it also makes things easier for us, because please remember, LINSTOR is using DRBD. DRBD is a real-time replication solution. And the real-time replication solution requires low latency, high bandwidth networking. And if you lack of that, then your primary performance also gets affected by it. So how do we solve it? And if there is a high latency, low bandwidth situations, we have a couple of possibilities to fix the situation. First, we can switch. Most likely, we will switch from synchronous to asynchronous replication, which makes a huge difference. And then, if that's not enough, we can use backup shipping possibilities. So we can simply ship the VM disks from one node to another with some scheduling actions. And with the stretched clusters or active passive clusters, we have the possibility to automate deployment and the configuration, which is very popular these days from what I see. The customers are always using Ansible-like solutions to automate all of the deployments, like adding new nodes into their clusters or removing them from the existing ones. They're always using deployment tools to deploy these kind of things. For example, this is another operational advantage if you choose a software-defined storage solution like LINBIT. And when it comes to the active-passive cluster, obviously, as it seems, you have an active data center which is running fully on your VMs, and you have another data center, DC3, which only holds the passive drives, which is secondary in DRBD's terms. So all of the secondary DRBDs are waiting. If a DC1 fails for some reason, VMs will fail over to the DC3 with the ability of the orchestrator, and then they will start running from DC3 automatically. And these types of setups might be might have some advantage over the stretch cluster in some point, and also stretch cluster has some advantages over active passive cluster. For example, when you have active passive cluster, you can have, let's say, less nodes with huge disks when you compare it with the active data center. With that way, you fulfill the requirement of having a replication over the another data center, and that might be just enough for the disaster recovery requirements. Because let's say you have 100 VMs running on DC1, but in your disaster recovery plan, you only need to fire up 10 of them, not all of them. So when that happens, you can only have less nodes on the DC3 and only replicate that VMs to the DC3, or maybe all of them, but only fire up the 10 of the VMs that you need, that you require. And again, DC2 in this situation can be configured as a management data center, which is really pretty cool. And or you can have like a mixed version of mixed VMs of a cluster, like a stretch cluster, but with 3 data centers. That's also possible. So your VMs will be stretched all over the data centers, one by one, load balanced completely. And please don't forget, I didn't draw the nodes on these clusters, but you always have to have odd number of nodes on each data center. So you cannot have like 3 nodes on the DC1, 1 node on DC2, 1 node on DC3. So if you have that kind of situation only with 5 nodes, that works, obviously. It doesn't give any errors, but it has some logic issues. So if you want to have a stretched cluster, you need to think a little bit bigger than 5 nodes. It has to be a little bit more than that. Or again, you can have like 2-2-1 or 2-1-2 situations. That's the explanation of the 3 data center deployment with LINBIT STS, to be honest. And that's the end of my presentation. Thank you for listening. I mean, in summary, so today's I joined LINBIT like 5 years ago, and 5 years ago the requirements were different than today's. So every day, what I get from the customers are surprising me, which is good, keeps me alive, keeps Gabor busy because he's building new features into the LINSTOR with those requests. But the thing is, in LINBIT, as a LINSTOR team, we committed to adapt these changes into today's requirements. And we understand that people, customers, companies needs to replicate data in between data centers, and we are making it possible with LINBIT solutions. Thank you for listening me.
Thanks very much, Yusuf. Very interesting, and always a pleasure to hear your presentations and enjoy sharing in your wealth of knowledge. We did get a question that came in from YouTube, and I think you partially answered the question later in your presentation. What about replication latency? Is DRBD proxy used for it, or is it built into DRBD itself? I think you mentioned dark fiber and DRBD's different protocols, but maybe you want to speak to DRBD proxy as an option, or
Yeah, I mean, I actually put it into my presentation on the right-hand side on the bottom. Optional proxy can be used for the rough connections. The proxy is always an option. The DRBD proxy is a tool. It works like a VAN optimizer in some of the cases. It's not a magic tool, but it fixes some of the flows of your networking. So we cannot simply rely on the proxy, like fix 56K connection between 2 data centers and try to replicate NVMe drives. But obviously, it helps on a lot of situations, especially when you have, let's say, high latency situations, as far as I know. So, but yeah, proxy can be used to mitigate those issues, generally speaking.
Okay, thank you. And there was a question that came into the chat from Akshat for Christoph. We'll hold off presenting that question until the very end to keep things moving here. And also want to mention that Niels posted a related LINBIT blog post that covers stretched clustering if you want to explore that topic further. While I'm handing out compliments, I noticed that Kuroki-san is in the meeting, so I recognize Kuroki-san from being on the team that translates LINBIT users guides into the Japanese language. So thank you, Kuroki-san, for your contributions there. Very much appreciated, making our users guides available to Japanese audiences. Moving on, our last presenter today is longtime LINBIT developer Robert, and among many development roles here at LINBIT, Robert is the lead developer of the open source utility DRBDmon. And for those of you who don't know, DRBDmon is part of the DRBD's utils package or GitHub repository, depending on whether you're a LINBIT customer or a community user. DRBDmon can be a very useful and powerful tool to manage DRBD resources, and especially when you have many DRBD resources. Here you can think of many as being a number in the hundreds, possibly. DRBDmon might be one of the lesser known tools that LINBIT develops, and Robert is here to change that and convert you all into users. With that, Robert, please take it away.
Thanks. Let's get right into it. What I would like to show you today is how to use this utility effectively. And it was originally only a monitoring utility that we developed for our internal use. And then once we didn't really have anything else, so users also used it. So at some point in time, I think 2 years ago, we decided to change the user interface and also to enable this utility to also manage DRBDs or change the state, not just look at it. So first of all, how to start it, obviously DRBDmon, that's also the name of the binary that you have to type. It's part of the DRBD utils package that also contains DRBD ADM, DRBD setup, and all those utilities. So I have 2 nodes here, actually 4-node cluster. I have 2 pulled up here to look at. And I'll split this presentation into parts. First of all, just basic usage. If you hardly ever use it, if you only have a few resources, then what are the most basic things that you can do with this thing? And then we will move on to some advanced usage where, especially if you have lots of resources, how can you effectively and efficiently use this utility? So once you're in here, first of all, what do you see here? Obviously the version, not really interesting. The next one is the node name. That can be interesting if you have like 5 of them open using SSH to different servers so that you can see what node you're looking at, because it only shows DRBD resources on each node. It does not show any remote resources. It doesn't show the entire cluster like LINSTOR would. It deals with the local node and the state of the resources on the local node. Then below that, depending on which display you are on, there are different displays for lists of resources, lists of volumes in those resources, lists of connections and stuff like that. It'll typically in list displays show you a header line that describes what the columns are, and then a list of all the items. In this case, if you start DRBDmon from the command line, you always end up on the resource list because that's the most interesting thing in DRBD. So from left to right, what you see here is there's a little bit of space to the left that shows you selection markers and alerts, alert symbols. And then this dot here means secondary mode. So the first column of the R is the role. That is hollowed. It's a hollow circle for secondary. It's a filled circle for primary. I'll show you that a little bit later. Then to the right of it is the resource name. So the name of your DRBD resource. And then the next column is volumes. That is split into 2 parts, just as connections. And then finally quorum. In the volumes and the connections columns, what you see is on the right side of those 2 fields is the total number of volumes and total number of connections for that resource. And on the left part is the number of volumes or connections respectively that are in a good state. So for example, here obviously all of those green resources. Green means no problems, no errors. One volume, and it's also working. 3 connections, all 3 of them are working. If you look down here, this is a resource that experiences some kind of problem. And as you can see, it has 1 volume, it has 3 connections, but that 1 volume isn't working correctly, and only 1 of the 3 connections is working as it should. Last column is quorum. This one doesn't have quorum, that's why it says no. The other ones say yes. And it's pretty obvious. Red means there's some kind of problem. Green means everything is okay. And if you look on the second or third page, you'll probably see some that have a yellow marker here. So there are 2 different kinds of markers. Red ones mean an alert, and alert normally means locally on this node something is wrong. So either the connection is not connected or the volume is not okay, something like that. Warnings are the yellow hollow triangles, and that normally means something on a remote node is not okay, and it has limited views of that, so it doesn't see everything that remote nodes do. We can look into this one a little bit later, and you'll see that there's a problem with a remote volume in this case. The flags appear, first of all, left to the resource. If there's any kind of problem or warning, then the entire resource will be flagged. And then the details are to the right. If it appears in front of volumes, then there's a volume problem. In front of connections, obviously there's some kind of connection problem. The next most important thing to know on these displays is that you not only can you look at different pages and what the state is of all of those resources, but you can also navigate to resources and show details. And to do that, you have to press the tab key. So tab enables a cursor that you can navigate with the arrow keys. If you press tab again, then the cursor disappears and you're back in page mode. So once you have the cursor, you can navigate to whichever resource you want to take a look at, for example, this one. And then if you press enter, you will see details describing what the problems with this resource are, or if there are no problems, obviously just what the state is. So in that case, it says, for example, status degraded because it's not working properly. And connections says there are 3 connections, 1 is normal, 2 are degraded, and 1 volume is there, but it's also degraded and it doesn't have quorum. So the interesting things here would be, first of all, the connections, because they're degraded, and you can navigate there with those hotkeys A, B, A, C, and V. C for connections, that puts you on the connections list for that resource. And again, same thing, you can press the tab key and you get a cursor to navigate, and you can navigate to the connection status. Enter again and you get connection details. It's exactly the same for volumes. So that is how you navigate. That is basic navigation in DRBDmon. To get back, F10 closes the display. So it basically puts you back on the previous display that you were on. And there's actually 1 display on top of the resource list. If you press F10 again, it puts you on the main menu display, where you can navigate to basically everything else. So you would want to go back to the resource overview, which is this resource list. You can do the same things using the mouse if the terminal supports mouse reporting and if it's turned on in DRBDmon, which is the default. So unless you turn it off, it's turned on. So you can just click on things, mark some resource, and if you press the right mouse button, which does not work on all terminals, or just be warned, some of them intercept that and use it for their own context menu. In that case, you'll just have to press enter on the keyboard. But if the terminal supports it and you click with the right mouse button, that does the same thing as the enter key. And you can also click those hotkeys, volumes, details for this volume, and things like that. In general, for everyone who's using DRBD, no matter what utility you are using, DRBDadm, DRBD setup, DRBDmon, doesn't really matter, even LINSTOR, how do you solve problems in DRBD? There is basically a cycle that works for solving any kind of problem. It's also true for DRBD, and that is, first of all, you need to get an overview of what's going on. Just look at what the state is. And there is a neat utility here in DRBDmon to get an overview of what all the problems are. That is pressing the P key, P as in problems. That's a tri-state switch. So if you press P once, it goes into problems auto, shown up here. And it limits the view to only show resources, volumes, and connections that have some kind of problem. Volume is not attached, connection is not connected, something like that. So everything that you see now is some reasons that needs something done to it to make it work normally. And then if you press P again, you can lock that to problems, meaning that even if no resources have problems, it will not show anything. We'll just say there are no resources with problems. In problems auto mode, if there are no resources with problems, it goes back to the normal resource list where it shows everything. Now that we have an overview, and you probably want the same overview on a different node so that you can compare what the problem is on each node. For example, this resource is the same on those two nodes. Now I can see I have a volume problem on this node, and on the other node, it says there's a connection problem. So I would probably want to look at the volumes first. The next thing is to figure out why the problem exists. So figure out what the situation is, what caused the situation. Are all the volumes that are detached in the same storage pool? Then you probably have a problem with the storage pool. Are all of the resources disconnected from the same node? You probably have that node down, most probably, or maybe it has a network problem. So try to make sense of what you're seeing. Then the next step would be to decide what you want to do with all those problems. So do you want to adjust? Do you maybe want to restart the node before you do anything? Decide what to do, and then finally you carry out those actions, and then you start over again, because just because you issue some command doesn't mean that everything is better now. You have to figure out what happened after you did that. So in this case, for example, this volume says up to date. It seems to work locally. There's some reason why it says the volume is not okay. Let's look at the resources, the connections. So all of those three, for example, say they're in standalone. Standalone meaning it's not trying to connect to the other node. And I can compare on this other node what this node is doing on the same resource, connections. It says it's trying to connect on this node, so that seems okay. Kratos, 8 tracks. 8 tracks is not trying to connect to Kratos, but Kratos is trying to connect to 8 tracks. So the only thing I need to do, most probably, is to call up an action here. There are two ways to do that. Either you navigate to the details and go to the actions, and then you select connect, or you can do it a little bit quicker and go directly from this resource line by pressing the A key for actions. Go directly to actions and select connect, number 1. And then obviously that worked. So it disappears from the problems display, and you can do the same thing for the other ones. Again, you can do it with the mouse if that is faster. And the final one, actions, connect. And this resource looks a lot better now. Also says problems in blue now on this connection list, because all of the connections are good. That's problems auto mode, as I said, problems lock. It would just say no problems. So that's the most basic usage of DRBDmon, is just looking at what's going on, one resource at a time. This one, for example, connection list. So this is the connection with the problem. It's also on this node, Kratos connected. It says the volume on Kratos has some kind of problem. There's one more view here that is peer volumes, and it says negotiating here. So if we go here on creators and look for the same resource, CF something that's over here somewhere, the last one. And I will also show you a function to find that a little bit faster. Then if you go to volumes here, then you will see that this one also says negotiating. And in that case, that's not even a bug that I introduced for today's training. That happened by accident. So this is a real life demonstration how to solve this. You probably want to disconnect and reconnect this resource on one of the nodes, probably here. So go to the resource, disconnect all of the replication links, and then reconnect them. And then it should go back to established, which is exactly what happened. And it disappeared from the problems view. Now for the advanced users, there is a possibility to do all of that a little bit faster, especially if you have problems enabled. There are selection commands where you can do select all. And if you're showing only problematic resources and you select all, it doesn't select all of the resources. It actually selects those that you can see. So even if you go back to the list of all resources, only the ones with problems are selected, and now you can run actions on multiple resources. Important thing here, you have to go to the actions page directly from the selection and not from a details page, because details pages are for a single resource and actions called from here are for that single resource. So you have to be on a list view to carry out actions on multiple items. So directly press A for actions, and then normally if something went wrong, the first thing you would want to try is adjust resource, because that just tells DRBDm to try and bring all those resources back to a normal working state. So if you do that, most of the problems are gone immediately. And then you can press F4 to cancel a selection. There are some problems remaining here. Same here, you can go back to problems if you want, and then figure out what the remaining problems are. Maybe they're on this node. Again, for selecting, you can also, if I go back to this view, you can also select using the mouse by clicking very far to the left on the resource line, and you will see those selection markers, and then carry out actions on these resources. And now all problems are resolved. You see problems auto goes blue instead of red, and it says no degraded resources. So advanced usage in DRBDmon is selecting resources basically and doing many things at once. What's new in this new version that you will get with one of the next DRBDutils updates is that you can select resources using patterns. So for example, if you want all of those data resources, you can do select asterisk data, and it marks all of the data resources, and you can run a command on those. For example, stop all of those. It's one possibility. If I go back to the normal resource list, then all of those disappear. Another important thing is selection and cursor remains active even if you can't see the item that is selected. Same for the cursor. If I stop this resource, then it still says cursor up here, even though you can't see it. But if you press enter, you will see that this resource is still selected. Unless you move the cursor, it stays selected. So you can, for example, restart it. And that's advanced usage here. There's also a command to place the cursor on a resource if you want to find something quickly. For example, if I see something here, 0828D8, and I don't know where this is on this machine, and I can just do cursor dash asterisk 0828D8, something that's unique, asterisk, and it moves exactly here. And there are a couple of commands for things like that. For example, you have a pacemaker error message that says def DRBD 1063 has a problem. Minor number 1063 is in this resource. The most important key in this whole thing is F1, if you ask me. Help, it says it right here. So wherever you are, if you press F1, you get a help text that explains what you can do, what the keys are, what the commands are that you can use. If you press F1 again, down here it says help index, then you get the index of all help topics. You just need to read the help on whatever you want to know, and you can figure out how stuff works and what all the commands are. There are pretty powerful commands in here. You can use the command line and type things in. I think it doesn't make too much sense for me to get even more into details here, because this thing has a lot of functions and features and details that you can do, and most of them are in the help text. Otherwise, we also have a forum where you can ask questions, and the Slack channel is still active, will be replaced by the forum. So if you have specific questions on how to do things with DRBDmon, then it's probably best to ask in the forum, and we will answer them what the best method is to do that. Otherwise, I have one final thing with regards to terminals, because some terminals like to act up and some operating systems block certain function keys. If something with your terminal doesn't work, you can use commands instead of, for example, instead of function 10, there's a close command to close the display. You can go to displays using the display command. You can go to the help and things like that, just in case that your command, your function keys don't work. Go to the main menu and things like that. So there's normally more than one way to do things in DRBDmon, and if one doesn't work, then the other one does. That's all for now. In one of the next sessions, I think we'll go into how to configure this utility, because you can reconfigure certain things and save that in a configuration file. And you can do that from the command line and distribute it to different nodes and stuff like that. But I will leave that out for today. And if there are any immediate questions, then you can ask them right now and I'll try to answer that. Otherwise, as I said, the forums. And thanks for your attention.
Thank you very much, Robert. A question did come in from a YouTube viewer, but I think you answered it during the later part of your presentation. Can DRBDmon handle bulk actions, for example, downing or invalidating and resyncing multiple resources at once?
Yep. So to go into a little bit more detail, some of them. So you can run bulk actions on resources, bulk actions on the volumes of a single resource, if there are multiple volumes, bulk actions on connections, and limited bulk actions on connections. So you can select 10 resources and disconnect all of the connections of all of those 10 resources. What it doesn't do is something like detach the second volume of each resource. That's something that it doesn't do because it doesn't make a lot of sense. Same thing for connections. That might actually make sense. We might add that in the future, where you can say, for all the resources, disconnect this single node. That might make sense. That's probably a feasible feature for the future. Right now, it doesn't do that. You can do bulk actions on multiple connections of a single resource. That's possible. And also bulk actions for large setups, you can run at most 1024 actions at a time. So at most 1024 actions, more or less. For example, 1024 stop commands can be queued. That is compiled in if you have very large setups and you frequently need to run more than, I don't know, 2000 actions at a time, and you don't want to split them up, then you might want to use a custom build of DRBDmon. It's very easy to change. We just rebuild it for you, 5 minutes, and you can run 4000 if you want.
Okay, thanks very much, Robert, for answering that question more in depth. So that's going to conclude the presentation as part of this community meeting. We did get a question for Christoph in the Zoom
Stop
chat.
the share.
And Christoph, that is, how exactly does LINBIT consume the highly available NFS share for a node running on the hypervisor? LINSTOR can only provide shared storage on LVM and not NFS or other file systems. Does it mount NFS as another file system? Actually, maybe Christoph has left the meeting early. I seem to remember.
I think I can answer that one too.
Okay. Thanks, Robert.
LINSTOR itself does not directly deal with NFS. Combines LINSTOR and NFS or LINSTOR and iSCSI shares, and also the VSAN uses the same component to do exactly that. So in the case of VSAN, you can have highly available NFS shares and highly available iSCSI as well, using the same component, which is LINSTOR Gateway. And you could also only use that component to automate that. Otherwise, LINSTOR itself doesn't directly deal with that. But if you have one of those additional components in use, then any remote nodes obviously can just mount the NFS as another file system. That's exactly how it works. I think the question might also touch on how VM clients, hypervisors that run VMs, get access to the DRBD storage nodes if they are diskless, and that is not via NFS. It is using DRBD diskless resources, so they do not have a local volume. They just replicate with storage nodes. It's kind of similar to iSCSI, but it only uses the DRBD protocol. If that was the question, because I'm not entirely sure what the question is, but I hope that answers it.
Yeah, I think you went into more depth there. Thank you. If that didn't answer the question, feel free to add clarifying question in the YouTube video comments or ask in our forums, which is forums.linbit.com. Thanks for the earlier plug there, Robert. And if you a couple other things to mention before we sign off here. Philip, LINBIT CEO and DRBD creator, couldn't attend today's meetings, but you can expect an update from Philip about where LINBIT software is headed generally in the future in an upcoming blog post on our website, and you can find our blogs at linbit.com/blog. And we also hope that you will join us for a special webinar that we are doing with VATES, and VATES is an open source virtualization stack company. And the upcoming webinar will dive into the launch of their ExoStore or XCPNG. And the reason we think this is cool is because ExoStore uses LINSTOR to do its magic. So join us for that webinar on June 26th. Unless there are other thoughts from RT or Niels, thanks for joining us today. And from the team here at LINBIT, we hope you always stay on.